Hello everyone and welcome to ixamBee. So this is the fourth video of software engineering concepts which is for the NABARD IT aspirants and for RRB IT aspirants. So here in this video we are going to talk about some of the very famous software development lifecycle models. So as this is the part 4, the earlier part 1, 2 and 3, you can go and watch those videos for more software engineering concepts for your examination. You can find the link in the description and you can go and check out those videos. So here in this video we are going to talk about the software development lifecycle model. So we have to first understand what is this software development lifecycle model. So whenever any particular software is developed, it has to go through a number of steps, and those steps are actually the life cycle of that software. Okay, so the evolution of a software takes place in some different steps, and those steps are actually categorized as models. They are being confined into different models. Depending upon the requirement of the development of the software, we choose a particular software development lifecycle model. So software development lifecycle model is nothing. It is just a methodology, different kind of methods which are involved in a particular model, which will help us to develop a software. So let us discuss some of the very famous model. So the very famous model is the classic waterfall development model. So this is the first model that came into the existence of the development of the software. So this particular model works on the waterfall principle. It means when water is flowing, as you can see in the image here, you can see if we pour the water from here, it will just go down and down and down. Okay, so this is kind of a water flow, okay, which is automatic in very nature. So here we start with the first step, that is the requirement analysis. Then there comes the design, and then coding, and then testing, and then the maintenance. So we will discuss what exactly these steps means to us. So requirement analysis says that whenever you are going to make any particular software, you have to actually gather all the kind of requirements. You have to gather the requirements that are necessary to make the software. Like what are the inputs that will be taken, what are the outputs that should be given, what are the specification, what are the requirements, what are the client specification. These all things you have to discuss and you have to codify them in your requirement analysis phase. So you have to very well document all the requirements that you want to have in your particular software. For an example, if you are going to develop an app which is just static in nature, which will just provide some PDF content to the user to read it out, so you have to provide that particular requirement in which particular scenario, what kind of user input and user output will be given. Okay, so here in this particular phase, all the requirements are analyzed, or you can also say the feasibility is also tested, whether this particular test will be passed or whether the particular software can be developed for some requirements or not. So feasibility study is also done in the requirement analysis phase. This particular phase is the first phase and the most crucial phase, because if you lose any particular requirement during this particular first phase, you won't be able to gather that particular requirement in the later on steps. So you have to make sure in classic waterfall model, if you are going to use it, that all the requirements are being gathered during the first step only. This particular is the most important and takes maximum amount of time from all the different steps that we have. After the requirements are analyzed, we go to the designing phase. So we design the particular software, how it is going to be looking like. Okay, so we develop our SDD document, okay, software design document, and depending upon that particular document, input is given to the coding step. Okay, so here this particular requirement analysis will be the input to design. Similarly, the design will be the input to the coding part. So depending upon the requirements and the things that are laid down in SDD, we do the coding part. In coding part, whenever we do the coding, we are actually just converting the requirement which are documented into the real-time existence and into the functionalities. After that thing, when our code is done and our software is ready, we do our testing thing, because anything cannot be released directly after its development. It needs some kind of testing as well. So we will do the testing kind of thing, and In this particular phase, depending upon the software, we can do as many kind of testing. It can be unit, it can be integration, it can be system, it can be alpha, it can be beta, it can be any kind of testing. Okay, there are so many types of testings: black box testing, white box testing. There are so many kind of testing. So depending upon the requirement, we do all the kind of testings here. After that thing, when the testing phase is passed, we go into the maintenance of the software. As the particular software will be used for a lot of time, for a more period of time, we need to maintain the software as well with the upgradation to the technology. Whenever our technology, that is underlying technology, is being upgraded, okay, so to cope up with that particular upgradation of the technology, we need to maintain our software also. We need to update the platforms. Whenever the platforms are updated, we need to just update our particular software as well. So this was the classic waterfall development model. This is very easy and simple going model. The one of the drawback that you can see here, that if you miss any requirement in the first step, there is no going back. You cannot just add on any requirement in the later phase. Suppose you are in your coding phase or you are in your testing phase and you saw that okay, some particular requirement is not being coded or is not being taken into account, then there is no going back to make them again. If you want to do that, you have to start from the very first cycle. Okay, so this is one of the drawback, that there is no going back. Okay, this was about the classic waterfall development model. This is the first model that used to develop the software. Then looking at the shortfalls of the waterfall model, we got to have this particular iterative waterfall model. So here all these steps are like same only, but what happens here you can see there are backward arrows as well. You can go to a backward direction also. It means, suppose if during the implementation state we found that something is being left out, okay, then we can easily go to the system design and the requirement analysis phase. So there is a going back thing which is there in the iterative waterfall model. So here we can go backward and we can include whatever is not included in the previous step. One thing I would like to point out here is like number of steps can vary, but actually there are only 3 to 4 steps that are majorly required. One is the requirement analysis, then you have the design, then you have the coding, then you have the testing, and then you have the maintenance. These can be further broken down. Like here the design is being written as system design, then the actual coding is written as implementation, then testing, then deployment. After the testing is done, the software is deployed. Okay, so sometimes under the testing umbrella itself only, the deployment testing is also done. So deployment is also taken into account. Okay, before the requirement analysis, you do the feasibility study that okay, if this particular software can be made at all or not, if we have the enough technological support for that. So don't go with just learning these steps. Okay, just to understand the importance of each step, what this particular step is doing. At the end, there are only these many 5 steps which are going to matter in every particular model. Okay, so this is the iterative model which just overcomes the shortfall of the classical model. Okay, coming to the third model, it is the spiral model. What happened in a spiral model? In a spiral model, you can see there is kind of spirals which are being drawn around into a particular XYZ axis. Okay, so what happens here? We make a particular this kind of a structure. Here we divide it into 4 quadrants. We have 4 quadrants, and these 4 quadrants are actually specifying different kinds of steps. Okay, so here this first quadrant will be your requirement analysis, then the second will be your design, the third will be your coding, and your fourth will be testing and risk analysis. So what happens in the spiral model? It says that you don't need to gather all the information at the first glance. Whenever you are going to start the particular software with the minimum requirements, you can just make one particular module of the particular software. Once you are done with the one particular module and you gather some other requirements, you can just again add those requirements into the existing module and you can go again. Okay, so this is the thing that we need to do. Once the spiral is ended in the fourth one, that is the testing and analysis, and all the modules are covered, then you can say your software is ready. Okay, so here you can see in the first quadrant, when we doesn't start with anything, it is just the risk management. This particular thing will actually going to monitor, this business need is going to monitor the feasibility study and the need of the particular software. After that thing, you have to do the risk management as well, whether the risk, how much risk is being involved there. Okay, so first particular spiral will be accounted only like this. Okay, you have to do the requirement analysis, and here you just need to analyze whether your system is feasible enough or your system meet the business needs as well. Okay, after that thing, you will do a architectural design. What kind of architecture you need to have? Like there is one famous architecture that is called as MVC, like model, view and controller. So you need to know which kind of architecture you want to have for your particular software. After that thing, you can build one particular requirement. Okay, it means that whatever requirement I have which are being documented till now, which are being designed till now, the part of SDD, I will just make those particular requirements codified. So you will code those. Okay, and you will develop one. After that thing, you will do a scheduled monitoring of this particular thing, that is the testing one of the first module. Then again you will check onto the system requirements. Then you will be going to design the modules. This particular step can go on into many other spirals, and so on. This particular things keep on moving. Okay, and every time you have to move from one process to another process, and you have to also review everything at a particular step. Okay, so this particular model works on this particular spiral principle. If your spiral is getting a lot many kind of concentric circles, then that is not too good. You have to confine actually yourself. Okay, it cannot be an endless task that your particular spiral is keep on increasing. Okay, so depending upon the requirements, you have to also manage the number of circles or the number of iterations you are going to have in your model, because every particular model will involve a lot of cost. So you have to take that cost as well whenever you are going to move from one process to another process, whenever you are going to move from the process to process. So this is the one thing. And after every particular last particular code is being done, then the software is being released, and then it is open for the testing and the risk analysis. So this was about the spiral model. The next model is the RAD model. So RAD model is a very famous model. It is being used very much in the industries. So here the rapid application development model works like, it says we are going to develop different prototypes for a particular application, and after that we will combine those application codes. Okay, and we will get our whole software. So here what is being done, at every particular step we are going to do the modelings. Okay, so business modeling means the requirement specification and gathering, how much the business is feasible enough. Then the data modeling, what all data are required, process modeling, application generation, testing and turnover. These are self-sufficient name. If you feel any kind of doubt in all those steps, then do comment. I will just clarify that what all these kind of things are. Basically, these are the steps which RAD involves. The data modeling, if you have provided this much data, what should be the output, then process, which kind of process we are going to follow, application generation, like the integration of doing everything, and then testing. Okay, so after these all prototypes are being there developed, we just use manual tool, or it can be done automated also. So we can just combine all these and we can get the application code. So here individually and parallelly, okay, so here individually the prototypes can be developed, also the parallel execution and maintenance and coding of every particular development of a prototype can also be done. So this will actually reduce the time that is being taken to develop. So we have to identify the modular components and we have to develop those modular components. After that thing, we have this incremental model. So what this incremental model says, this is also somehow related to your RAD model. Just a name is being different and some of the methodologies are being different. So here the requirements are being gathered and those requirements are actually broken down into different modules. Okay, that particular requirements is just broken down into different modules and we build those modules. We start from the design and development, testing and the implementation. And whenever all these things are being there, then we are actually going to combine them to get our major software. Okay, so this is also somehow related closely to the RAD model, but here all the requirements are being gathered at the first, and then when we divide our requirement, the requirements are divided after this thing. So this is an incremental model. Sometimes what happens, one module is being developed, that is increment 1, then it will help to make a increment 2. So somehow if you have any related modules and one module is dependent on other, so you have to make sure, okay, the first model is being made, then I'm going to make the other module. So incrementation model deals with that also. If one build is developing and it is dependent on other build, or that particular build is going to be input to other build, that particular thing is also taken into the incremental model. So we design our software in an increments and we combine those increments. After that thing, we have agile methodology. So agile methodology is a very new methodology. This is actually the future of the software development. So what happened in agile, we know that the development of the software is a time taking process, and we have different kind of models which are trying to reduce that particular time and to go with the on time deliveries. So agile model says that this particular model provide the very much flexibility, the maximum flexibility to the new requirement. Maximum flexibility to the new requirements is being present. It means if you have any new requirement at any point of time, it can be development, it can be maintenance, it can be anything, you can just accommodate that particular requirement. So maximum flexibility is required. Then the next thing that the agile model help us is to involve the customer very closely with the development. Okay, customer is very closely related to the development that is being going on. It means if customer has provided you some modules and it wants that this particular module M1, M2 and M3 are the part of my software, and I want to develop M3 on the high priority, then the M3 will be taken up in the development. So there is a close link between the customer and the development. So customer's requirement are treated as the highest priority. Okay, after that thing, the time of developing is also reduced and the deliveries are very fast. The deliveries of software are very fast. And it includes a span of like 1 week to develop a module to maximum 4 weeks. Okay, so there are actually sprints which are being planned here. So sprints are planned, and depending upon the sprints, the length of the sprint and the requirement that are being specified in that particular sprint, the particular software component is developed. Suppose there is a software, okay, and there are several modules of it, and we are into the development of module 2. So what will happen, we will just see, okay, we have to develop module 2. In that module, we will need at least 4 weeks. Okay, but in those 4 weeks, we can divide it into 2 sprints of 2 weeks each. Okay, so what will happen in the first 2 weeks, we are going to design some components of M2, and in the second 2 weeks, we are going to design the second 2 components, and we are going to integrate those also in the next 2 weeks. Okay, so by this we plan the sprints and everything goes on. So here the tracking of the software development is also very good at every particular step, and the transparency is also very increased, and you get to know the deficiency in the system at very early stage. So early testing is also possible here in this particular agile. So agile is very widely used and very widely acceptable in the industries. Whenever most of the industries are involved in the real-time softwares, that they goes with this particular agile methodology. So what happens here, you have to plan what type of things you want to have in your software, then you have to make a pre-design. After that thing, you have to develop it, you have to test it, you have to deploy, you have to review. Once that particular thing is done, you can go for a launch. Okay, then again you can do the same step. It is in a cyclical mode. Okay, so everything is being done depending upon the number of sprints and the length of the sprints. Usually the sprint goes from 1 week to 4 weeks. That is the agile methodology. Then one of the key concepts of the agile methodology is your extreme programming. Extreme programming is actually the methodology of agile only. It is not a different kind of technique for software development. It is a part of agile only. So you can see that I told you there are small releases that are planned in agile. Whenever there are softwares, these softwares are being broken into modules. These modules are broken into sub-modules, and the sprints are planned. Okay, sprints are planned, and according to those sprints, we do the development of the life cycle of the particular software. Okay, so what happens here, first we actually have to make a story that what kind of things we want in a particular thing. So first stories are made, that too in a like different manner. We have Kanban approach, we have different kind of approach. So first we have to just portray a particular story that this particular thing is being there. We have to set the agenda. Basically in the story part we are going to set the agenda for the development. After that thing we have to make a release planning. In the release planning itself we have to make the estimates. If the estimates are spiking up, if your cost is increasing or not, so you are going to maintain the track of your cost as well in the whole process of programming a particular software. Okay, if the spikes are being there, it means the cost is being increasing, then you can again make a release plan and you can inform the customer, okay, we are involving a high cost here, or the resources required more here, or the development tools are being needed here, or whatever the underlying technologies are being changed, whatever the parameters are there which can make a spike into the estimates, you can just make those count during the release planning. So in the release planning you have to first go with every requirements, put up your agenda in the stories. You have to make a release planning that okay, in this particular month I am going to release this particular software, in that particular month I am going to release 50% of the software, then 30%, or whatever it is. Okay, so release planning is being done with taking into account the cost estimates as well. After that thing you have to develop and make everything here in the release, everything coding and designing, all the things take place. After that thing acceptance testing is being done. During the acceptance testing, you whatever the agenda were portrayed in your stories, you have to develop them into the form of a test scenario. You have to make the test cases and you have to check that particular thing on the acceptance testing whether that particular requirements are incorporated properly or not. If those requirements are not incorporated properly, then again you have to go to the release planning. You have to make those particular components again and you have to do the iteration. During this particular backward iteration, it may also involve the spikes estimates. Okay, the spikes in the estimates. So we have to move here also. So this particular thing, you can see that all the factors are being taken into account very closely to each other. And there is no way out that we can leave any dimension out. Once the acceptance testing is passed, the customer approves your particular software module, it is being set to release. There can be a major release, there can be small releases as well. Suppose this particular software involves 4 modules and these 4 modules are developed, so it will be a total release. Otherwise, suppose this much is only developed, then this is a small release. Okay, so depending upon the requirements and the age and the maturity of this software, releases are being planned. Those can be small and those can be full release as well. Okay, so I hope you understand all these particular methodologies of developing the softwares. So this was all about the software development life cycle models and I hope you guys understand it very well. If you find any kind of doubt, you can just leave the doubt in your comment section. I will say there are many more software methodologies out there, but we don't need to study each and every in so much detail. These are the major things that are being asked from the exam perspective. You don't have to go and run behind every particular thing that is out there for reading. You have to just cut down to the important ones. Okay, so here I try to import those all important concepts for you. Hope you guys understand that very well. So if you like this video, do hit the like button, and if you are an unsubscribed user and you want these kind of videos regularly on the notification, then do hit the subscribe button and press the bell icon so that you can get the notification whenever we upload any videos on the IT1 and other particular subjects. So for that time, I'll take a leave. Keep practicing and stay updated.